Okay, so hello, this is another step question. This is number 2 on paper 1 1998. By the way, this doesn't mean that I'm going to do all the questions on the paper, but I'm thinking about doing maybe just a few of them. So far I've looked at the first, I think, 4 questions, and yeah, some of them are interesting, some of them seem rather shorter or easier than normal, but it's very difficult to make that judgment, to be honest. Now, this is question 2 on the screen. Please do have a look at it. Try to do this question, if you like, in advance of watching the video. And I'm going to start talking about my answer now. Okay, so there are only 2 parts to the question. Little unusual, but okay. In the first part, we are asked to show by means of a suitable change of variable, or otherwise that's a certain thing, and then hence or otherwise show something else. So first of all, the or otherwise, what do we know about those? Well, usually we should understand that or otherwise is something that you just ignore. Okay, you don't, under no circumstances would I attempt to use otherwise in any question in STEP, unless you're in a very rare situation that you A, are unable to do the question using the normal method, and B, you have a very good reason that you think you can do it another way. The only case I can think of is when you actually have already done this question or something very similar and know a special technique to do it. But yeah, like, basically just forget it. Now, I would say the theme of this question is really, having done it, the theme of this question is use the answer as a clue. Something you can very often do is, if you're given an answer and that answer is more than just a number, because obviously if it's just a number that doesn't give you any clues, but if you're given an answer which is a formula, you can often look at some features of that formula to help you solve the question. So let's try and keep that idea in mind as we go through it. So the first step is to use a change of variable to show the given formula. Excuse me. Now, if we're going to change the variable or do integration by substitution, then we have to look at the final result and ask ourselves what specific features it has. Well, the most obvious feature that jumps out is this use of a function, which is not specified. It's just called f of x, and what we notice is that the use of the function has changed dramatically. And on the left, that we're taking the function of a very complicated formula for x, but on the right we're just taking f of t. So if you think about it, it doesn't take too long to realize that the only substitution that makes any sense is substituting t for exactly that formula for x. And of course the first thing one does with the substitution is always to find the derivative of that substitution. Here we can use the chain rule and we get 1/2 and then 2x and then x squared plus 1 to the power of negative 1/2 and plus 1, and of course don't forget the dx on the end there. Now, when we do a substitution on a definite integral, we should never forget to check the limits. If we have x equals 0 on the left, so when x equals 0, we substitute 0 into this formula, we get 0 squared plus 1 to the power half plus 0, so t would be 1, which is exactly what we want. We see that the figure 1 appears here. So that gives us a lot of confidence that we've made the right choice, or some confidence that we've made the right choice about substitution. And obviously for the other limit, infinity becomes infinity. So that's fine. Now then, what we're going to have to do now is try to use that relationship between x and t to build the new version of the integral going from left to right so that it looks correct as it is in the question. Just going to make a new page here. Okay, so make so going from left to right. Now, the substitution we've made so far will give us something like this. So perhaps I can write therefore. the integral from 0 to infinity of f of x squared plus 1 to the power 1/2 plus x dx is equal to the integral from 1 to infinity of, now we still have f of t, so t being exactly that thing, but dx is equal to dt over that complicated formula, so it's going to be dt over, sorry, let me just use a better straight line there, dt over, and this complicated formula we have simplifies a little bit to x over root x squared plus 1 plus 1. I think you'll agree with that. Now then, if we, obviously that's not the final answer, is it? Because we need, so this is what we have. If I can mark on, I always have to be very careful with the pen on this software. This is what we have, and what we need is something that looks quite different. It's 1 plus t to the power minus 2, sorry, ft dt. So our task has become to demonstrate that those two things are the same. So if perhaps the natural next step is to simplify as much as possible what we have at the moment, and then see how we can make it, we can prove that it's equivalent to the thing that we need. So simplifying that down a little bit, we would get x plus square root x squared plus 1 all over square root, no, I'm sorry, this is the wrong way around, isn't it? Well, I'll just write it out in this form, it's fine, to the power negative 1 ft dt. And obviously we can flip that fraction over, but we can also notice that the numerator of the fraction we see there, x plus square root x plus 1, is in fact equal to t. So that's a simplification already. So I could write that as t over square root x squared plus 1 from 1 to infinity ft dt. So at this point we stop and look and we say, this does not look exactly the same as what we want. We need 1 plus t to the minus 2. But if we were to just naively substitute and say, well, I just need everything to be in terms of t, not x, the problem is that the original formula, if I can mark that in blue here, the original formula had t written in terms of x, but to write x in terms of t is a bit more complicated, right? Because of that square root, we'd need to write something like x squared plus 1 to the half equals t minus x, square both sides, and then think carefully about what's the exact correct formula. So that is one approach, but it seemed to me that a more natural approach, perhaps ultimately it comes down to the same thing, but it seemed to me that a more natural approach would be that when we look at this, which is what we're seeing in the formula given in the question, again using the answer as a clue, it seemed to me that the more natural thing to do would be to find what t squared actually is, and then we could demonstrate that in some way that t squared plus 1 over t squared would in fact simplify down to the same as t over root x squared plus 1, because that's all we need to know. So that's why my next step was just to write, okay, what is t squared? So I said, okay, t squared equals what we had before, x plus root x squared plus 1 all squared. So that becomes what? X squared plus x squared plus 1 being the square of the square root of x squared plus 1, and plus the cross terms 2x root x squared plus 1. Okay, so far it's looking fairly complicated, but then again, if we're going to consider, well, let's just simplify that a little bit. 2x squared plus 1 plus 2x root x squared plus 1. And now I'm thinking, well, the term outside the square root, 2x squared plus 1, is similar to x squared plus 1 inside the square root, but it's not identical because of that 2. But then I remember, oh, hold on a minute, we're going to add 1 to this quantity, and then it will become much simplified. If we add 1 to both sides, we've got 2x squared plus 2 now, plus 2x root x squared plus 1. And now it's starting to become obvious that this is something that can factor out. I hope you can see that. Because now, both inside the square root on the right and on the left, we've got the term x squared plus 1. So we can take a common factor there, and the common factor is 2 times the square root of x squared plus 1. And then on the sorry, why isn't that working? On the left, we've got remaining x squared plus 1, and on the right, we've got x. And at this point we see what we needed to see, which is that we see the term t appearing, and as desired it's multiplied only by the square root of x squared plus 1, which is exactly what we've got in our version of the integral up here. So I want to reiterate that that approach was not the only one. My approach was to notice that in the answer I had the term t squared featuring, therefore to find out what t squared looked like, and then to recognize that in fact adding 1 creates a significant simplification which ends up in the position that we want. You might have approached it differently by trying to isolate x, and that may or may not have worked, but I could see that this is likely to be a good idea. Let me actually make a note about this. Likely to be a good idea. Because it was squaring, and because squaring is see, let's say going from there to there by squaring, although it makes the equation more complex, it doesn't create any more nasty roots. It doesn't create fourth roots or something, or complicated objects like that. But anyway, let's not get too sort of psychological about the whole thing. I mean, this is just a logical sequence, and if you found the right answer another way, well done. Let's just finish off. So far we have that t squared plus 1 is equal to 2 times root x squared plus 1 plus t. So if I want, as I do from my version of the integral up here, if I want t divided by root x squared plus 1, then I'm going to have to divide both sides by t squared. And now we can see that if we flip it over and move the 2 to the other side, we get exactly what we want. So if we take the reciprocal of both sides and divide the left hand side by 2, so let's see, one step at a time. Hang on, which way around do I want to do this? T over root x squared plus 1. So, well, let's just do that. So t over root x squared plus 1 would be equal to t squared, hang on, which way around is this? 2t squared over t squared plus 1. Is that right? Therefore, the integral we had before would be from 1 to infinity t over root x squared plus 1. Oh, hang on. I forgot to do to the minus 1 power here, didn't I? My mistake, sorry. There's a minus 1 there. So let's write it in the correct form. Root x squared plus 1 over t ft dt from 1 to infinity is equal to integral t squared plus 1 over t squared times 2 there, ft dt on the same limits. And let's just double check that is the answer we were aiming at. Yes, okay. Obviously t squared plus 1 over, let's just write it exactly, is equal to 1/2 integral from 1 to infinity 1 plus t to the power minus 2 ft dt. Okay, so we got there in the end. Now it was a bit complicated, and I would say that is the tricky part of the question really. This part here is really the important bit. I won't say any more on it. If you found a different way to do it, that's great. Okay, let's look at the second part. Hence or otherwise show that this integral given and is equal to this number 3 over 8. So as I said before, the number 3 over 8 obviously is not any kind of clue. So in this case, it's just simply a matter of, can we use the first part of the question to answer the second part? And we see obviously that we can, because this expression x squared plus 1 to the half plus x, which we defined as t, appears again here exactly the same. So clearly we can apply the above formula with f of x equals x to the power of minus 3. So let's just do that directly. So we're going to, so this is part B, use f of x equals x to the minus 3. We can say integral from 0 to infinity x squared plus 1 to the half plus x all to the power of minus 3 dx must be equal to the integral from 1 to infinity of 1 plus t to the power minus 2, and then f of t is t to the minus 3 dt, although we need a 1/2 there. And so we can see the integral on the right is very simple. So this is actually a very unusual step question. I think maybe a badly designed one, in that the second part of the question is not only as easy as the first part, but extremely easy in comparison to the first part. So it's really not actually worth doing this second part. So I think maybe the people who wrote this, some of these questions, weren't perhaps well experienced in writing questions. So I'll just run through it. It's not very interesting, is it? T to the minus 3 becomes t to the minus 2 over 2 when integrated, and t to the minus 5 becomes t to the minus 4 over minus 4 when integrated, and the limits are 1 and infinity, and there's a factor of 1/2, so it's equal to 1/2 times, now obviously when we put infinity we're going to get 0, so we've got to be a little bit careful about minus signs. So 0 minus, and then inside the brackets, inside the substitution of 1, I'm getting minus 1/2 and minus 1/4 there. Okay, so all those negative signs cancel. I get 1/2 of 3 over 4, which is equal to 3 over 8 as required. So yeah, I hope that was a little bit useful. I'm not sure, maybe. And I'll probably look at question 4 next, although I'm not actually sure. So thank you very much. See you again soon.